Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Next, we need to find all the solution to the equation 16z to the power of 4 equals to z minus 1 to the power of 4. So the first step is to rewrite the equation as z minus 1 over z to the power of 4 equals to 16, and we let it to become w. So the equation becomes w to the power of 4 equals to 16, and it is also equal to 16 times 1, where 1 is cos 2k pi plus I sine 2k pi. Next, we will be using again the De Moivre's theorem, so divide the other side by 4, so we obtain cis 2k pi over 4, where k equals to negative 1, 0, 1, and 2, since there are 4 roots. And then we substitute the k values and we obtain 2 cis negative pi over 2, 2 cis 0, 2 cis pi over 2, and 2 cis pi, which can then be simplified into negative 2i, 2i, and negative 2. But rearranging w equals to z minus 1 over z give z equals to 1 over 1 minus w. And we have all the 4 w's values, so we are going to substitute all of them in. So the 4 roots for z are 1 over 1 plus 2i, 1 over 1 minus 2, 1 over 1 minus 2i, 1 over 1 minus 2. Simplifying by rationalizing the denominators give z equals to 1 over 5 times 1 minus 2i, negative 1, 1 over 5 times 1 plus 2i, and 1 over 3. As you can see, the complex roots occurs in conjugate pairs again. Next, we want to look at the theory of finding the summation of series. In using complex number to facilitate finding the sums of certain series, the following results are found to be extremely useful. So we use z equals to cos theta plus I sine theta, which is also equivalent to e to the power of I theta. That's the Euler's theory. Then 1 plus z equals to 1 plus cos theta plus I sine theta. And we know that 1 plus cos theta, using the double angles formula, we can convert it into 2 cos 1 over 2 theta squared. And then, again using double angle formula for sine theta, we can use its identity, so 2i sine half theta cos half theta. Then we factorize the cos half theta out and we obtain this expression. Also for 1 minus z theta, we again write 1 minus cos theta minus I sine theta. And we convert it again using the identity, and we have 2 sine squared half theta minus 2i sine half theta cos half theta. But in this case, we are going to factorize out sine half theta, and we will have this expression, but we don't like it in terms of sign, so we are going to change it, the first term, to become a cos. So sine half theta is also equivalent to cos pi over 2 minus half theta. And similar to that for sine. And we want to eliminate the negative sign, so we just use another identity and changing it into this form. The other identity that will be very useful is z1 plus z2 star equals to z1 star plus z2 star. Also, z1 times z2 star equals to z1 star times z2 star. And finally, z star equals to cos theta minus I sine theta. Again, we use the identity to eliminate the negative sign. So we have cos minus theta plus I sine minus theta. And represent it into Euler's form. So e to the I negative theta or e to the negative I theta. And hence z to the power of negative 1. So we'll be using a few of these identity in the examples that I'm going to show you later. So let us first look at this. We want to show that the sum of cos k theta from 0 to 5 equals to sine 3 theta cos 5 over 2 theta times cosec half theta. So the first step is to convert cos k theta in terms of complex number. So cos k theta is also equals to the real part of e to the ik theta. And we know that e to the ik theta equals to z to the power of k. So we want to find the real part of the sum of z to the power of k from 0 to 5. And if you remember in P1 you have learned the formula of the sum of geometric progression. That formula is a times 1 minus r to the power of n over 1 minus r. So we want to find 1 plus z squared plus z cubed until z to the power of 5. So using the formula, we know that r is z and a is 1. So we want to find the summation. So it is the real part of 1 minus z to the power of 6 over 1 minus z. And this is still the complex form. So we are going to rationalize this by multiplying its complex conjugate, 1 minus z star. And we know that the identity that 1 minus z star is equals to 1 minus z star. But then the star will comes into the bracket. And then we are going to simplify this expression. We convert all the z star into negative 1, and we also know that z times z star equals to 1. At the denominator, we have z plus z star, which is z plus z to the power of minus 1. And we know that its identity is 2 cos theta. And then we also want to convert the numerator into its real part. So z to the power of 6 is cos 6 theta, z to the power of -1 is cos -1 theta, which is cos theta. And z to the power of 5 is cos 5 theta. Now we use the double angle formula to convert 1 minus cos theta into 2 sine squared half theta. And factorizing the minus out, we have minus cos 6 theta minus cos 5 theta. Similarly, for the denominator, we factorize the 2 out so that we have 1 minus cos theta and change it into 2 sine squared half theta. So the denominator is now 4 sine squared half theta. And then the next step is to convert cos 6 theta minus cos 5 theta using the identity into negative 2 sine 11 over 2 theta sine half theta. Because we know that cos p minus cos q equals to negative 2 sine p plus q, or 2 sine p minus q over 2. We now factorize out the sine half theta and cancels it with the denominator. And what we have is sine half theta plus sine 11 over 2 theta. And we also know the identity of sine p plus sine q equals to 2 sine p plus q over 2 cos p minus q over 2. So we can change it into 2 sine 3 theta cos 5 over 2 theta. And hence, we have obtained our expression when the 2 cancels out. In this next example, we want to show that the sum of 1 over 2 to the power of k sine k theta. And since it is a sine, we know that it is the imaginary part of the e to the power of I k theta. And we change it into z because z is e to the I theta. And then we factorize the k out. So we have the imaginary part of the sum of 1 over 2 times z to the power of k, which is equivalent to 1 plus 1 over 2z plus 1 over 2z squared plus dot 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 plus 1 over 2z to the power of 7. And again, using the sum of geometric progression formula, we know that a is 1 and 1 over 2z is the r. So substituting it into the formula, we obtain 1 minus 1 over 2z to the power of 8 over 1 minus 1 over 2z, which can be simplified as 256 minus z to the power of 8 over 128 times 2 minus z. And we want to rationalize it, so we times it with 2 minus z star. And using the identity just now that you have seen, we move the star into the bracket. So 2 minus z star again. And then we solve for the complex conjugate by simplifying the whole expression. And we have 512 minus 2z to the power of 8 minus 256 z star plus z8 times z star over 128 times 4 minus 2 times z plus z star plus 1. Now, we convert all the z star into -1. And we know that z plus z star is 2 cos theta. And we can further simplify this expression. And finally, we want the imaginary part of this equation. So, we take, for all the z, the sine part out. And we are left with sine 7 theta minus 2 sine 8 theta plus 256 sine theta over 128 times 5 minus 4 cos theta. And that's our answer.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.